Hey there. Those of you who are not in class today, I hope you had a very good weekend and are feeling lots better. I am going to show you a little bit about what we're going to do for the next couple of days. This is another method of finding a volume, and it's very similar to the disk method. Just instead of rotating an area around an axis, and your axis being one of your boundary lines, we're now going to have an area where you're rotating around something that's not a boundary line. The process is the same. Draw the base, draw the edge, draw the cross section, find the area, the limits of integration, just like before. But this time, instead of rotating something, let me see if I can just move this right here. This is kind of the easiest way to see this, that when I rotate this piece around the circle, see how it touches the axis of rotation? When I rotate it around, we talked about this the other day, it creates a circle, a disk. And that's what all these figures are, disks. But what if, instead of our boundary line touching our axis of rotation, we had something like this? Okay, so this is, read it right down here, the region between y equals 4, which is the purple line, and y equals x squared, which is the red curve, is revolved around the x-axis. Now notice, this is the area, but this right here that I'm revolving isn't touching the axis of rotation. Look over here on the right. Watch this side as I rotate it. We end up getting a donut, or a circle with a hole in it. Okay? This over here is called a washer. It's a washer because it has an outer circle and an inner circle. The formula is going to be is very similar to the formula for a disk. Remember, what is it? It's really a circle. Well, it's a circle with the middle removed. How do we remove things in calculus? Subtraction. So what the next lesson is going to be about is looking at these bounded areas and rotating around an axis, and this time we'll have a subtraction problem. All right, this is all I really wanted to do, was to show you. Now this is actually cool. I didn't really notice that I could do this. Let's look here for a minute. We rotate it around. What they're doing here is showing the outer radius and the inner radius. The blue is the outer radius, the red is the inner. So when we rotate it around, let's get this around here. You see, we can see it going around, and there is the outer radius goes all the way to the top and inner radius goes to the bottom. So we're going to talk in class about all the things that this means. But I just wanted to give you an introduction to some pictures that I would not be very good at doing on the board. All right? I'll see you tomorrow.